So welcome back to my video lecture 4 on S block elements. So hope you have watched my previous videos on S block elements. So in our previous video we understood what are S block elements, what are alkali metals, what are alkaline earth metals. We understood their electronic configuration, and we have explained a lot of physical properties of alkali metals and alkaline earth metals simultaneously and also in comparison with each other. Which are the physical properties that we have explained? We explained their electronic configuration, atomic radius, ionic radius, valency, ionization enthalpy, metallic character, melting point and boiling point, density, and lastly I said the most important aspect of S block elements that they impart color to the flame, and I have also discussed which element will impart which color to the flame. So now in this video we will be speaking about the chemical properties of alkali and alkaline earth metals. Chemical properties of S block elements or alkali and alkaline earth metals. Chemical properties. In particular, we will speak about the first chemical property, that is their reactivity. Reactivity towards reactivity towards oxygen and water. We will understand these two reactivities today. These two chemical reactions today, regarding alkali metals and alkaline earth metals. Yes. So shall we start with the reactivity towards oxygen now? Yes. We will study the reactivity of alkali metals and alkaline earth metals simultaneously. Yes. First we will speak about alkali metals and then about alkaline earth metals. Reactivity towards oxygen. The first reaction is reactivity towards oxygen. Reactivity towards what? Oxygen. Look here, when alkali metals, which are the alkali metals that we are dealing with? Lithium, sodium, potassium, rubidium, cesium. When these alkali metals react with oxygen, don't worry about balancing the reaction. Just try to understand the concept. Try to understand the product that is formed in these reactions. That's it. You don't have to worry about balancing the reaction, because we have already finished balancing the reaction in redox reactions, isn't it? So based on that we can balance the reactions, but balancing the reaction is not necessary here. Our intention is to learn what products are formed in various reactions. That is the concept here. So when lithium reacts with oxygen, when sodium reacts with oxygen, when potassium reacts with oxygen, rubidium is reacting with oxygen, cesium is reacting with oxygen. Look at here, when lithium reacts with oxygen, lithium reacts with oxygen, it forms normal oxide, that is lithium oxide. What does it form? It will form normal oxide. Normal oxide. Understood? Whereas when sodium reacts with oxygen, it is going to form what? What does it form? It will form sodium peroxide. What is the formula for sodium peroxide? Any idea? If you don't know how to write the formula of these oxides, these oxides, look at here. See, please remember, O2 minus, this is called as oxide. Oxide. O2 2 minus, this is called as superoxide. Yes, O2 minus, this is called as peroxide. O2 2 minus is peroxide. O2 minus is superoxide. Yes, are you getting my point? O2 minus is oxide, O2 2 minus is peroxide, O2 minus is superoxide. Now here you write lithium, then sodium, then potassium, rubidium, cesium. Okay, so lithium is reacting with oxygen. It is going to form normal oxide. What will be the formula of the normal oxide? You just have to cross multiply. Now, if you want to write the formula, crisscross multiplication. Yeah, multiply 2 charge here. Okay, and the 1 charge of lithium to this side. That's it. We know lithium will be in +1 state, correct? Okay, yes. So what will be the formula? It will be Li2O, correct? Normal oxide. What happens when sodium reacts with oxygen? It will form, okay, sodium peroxide. What is the formula for sodium peroxide? Na2O2. Okay, multiply the charge. Here 1, here 2. Multiply the charge. 2 ones are 2. That's it. Okay, so what type of oxide is it? It will form, okay, sodium is going to form what? Superoxide. Sorry, sodium is forming peroxide. Peroxide. Is this correct? Yes. Okay, whereas when potassium, rubidium and cesium reacts with oxygen, they form superoxides, guys. What is the formula? KO2, RbO2, CSO2. These are called as what? Superoxides. Superoxides. Understood? Okay, observe the formula. 1, just cross multiply. Okay, KO2, RbO2, CSO2. Okay, see, whenever any element, I said, okay, in the beginning of S block elements, we have 118 elements. If any element reacts with oxygen, it forms oxides. Okay, but we have got different types of oxides here. Look here, when lithium is reacting with oxygen, it will form normal oxide, that is lithium oxide. Whereas sodium, when it reacts with oxygen, it forms sodium peroxide. Whereas the next 3 elements, potassium, rubidium and cesium, when they react with oxygen, they form superoxides. Point to be noted. Very, 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 very important. Lithium with oxygen, normal oxide. Sodium with oxygen, peroxide. Rubidium, potassium, cesium with oxygen, they form superoxides. Superoxides. Any doubts? Just this, that's it, nothing else. Okay, so lithium, normal oxide, sodium, peroxide, potassium, rubidium, cesium, superoxide. Just try to learn how to write the formula. What is the formula for normal oxide? O2 minus, sorry, O2 minus. Peroxide O2 2 minus, superoxide O2 minus. You just have to cross multiply. You will get these formulas of various oxides. What is the formula for okay, lithium oxide? Li2O, sodium peroxide Na2O2, potassium, the superoxides of potassium, rubidium, cesium, KO2, RbO2, CSO2. Okay, simple. Any doubts? No doubts. Okay, look, but okay, when alkali metals are dissolved in liquid ammonia, when alkali metals are dissolved in liquid ammonia and then reacts with oxygen, all of them will form okay, normal oxides. Will form what type of oxides? Normal oxides. Are you getting my point? Okay, yes, point to be noted. Very, very, very important concepts. These are all very, very, very important. I'm telling you, when alkali metals are directly reacting with oxygen, they form different types of oxides. Okay, normal oxide, peroxide, superoxide. But if alkali metals are first dissolved in liquid ammonia, if they are first dissolved in liquid ammonia and then reacts with oxygen, all of them will form what? Normal oxides. That means, okay, when lithium dissolved in liquid ammonia, okay, reacts with oxygen, it forms normal oxide. What is the formula? Li2O. Correct? Okay, don't worry about balancing the reaction. Don't worry. Okay, when sodium dissolved in liquid ammonia, okay, reacts with oxygen, it will also form normal oxide. There is no distinguishing character here. Okay, when potassium dissolved in liquid ammonia dissolved in liquid ammonia, reacts with oxygen, this will also form normal oxide. Normal oxide. When? Okay, yes, rubidium dissolved in liquid ammonia. Dissolved in liquid ammonia. Okay, it also formed what? Normal oxide. Correct. Okay, when cesium dissolved in liquid ammonia. Liquid ammonia. Okay, reacts with oxygen. This forms normal oxide. So all the alkali metals, when dissolved in liquid ammonia and then reacts with oxygen, all of them will form same types of normal oxide. But if they react directly, if they react directly without dissolving in liquid ammonia, they'll form different types of oxides. We have normal oxide, peroxide and superoxide. Did you understand the difference here? Did you understand the difference here? Okay, simple. So what happens when alkali metals reacts with oxygen? They form oxides. When they react directly, they form different type of oxides. But if they are first dissolved in liquid ammonia and then react with oxygen, they form same types of oxide. Remember, all these oxides, all these oxides and all these oxides, okay, all these oxides are basic in nature. They are basic in nature. Understood? All the oxides of alkali metals are what? Basic in nature. Okay, so that means if they are basic in nature, okay, obviously they'll react with acids, isn't it? So all these oxides and all these oxides are what in nature? Basic in nature. Okay, so it means, see this, see this, okay, very important. Okay, look here, lithium oxide formula Li2O, it is basic in nature. Okay, sodium oxide Na2O, it is also basic in nature. Potassium oxide is basic in nature. Rubidium oxide is basic in nature. Cesium oxide is also basic in nature. All these oxides are what? Basic in nature, isn't it? All these oxides are basic in nature. Is that correct? Okay, we know bases will react with acid to form what? Salt and water, isn't it? Salt and water. But yeah, correct. Here also, what happens when lithium oxide, now sodium oxide, potassium oxide, rubidium oxide and cesium oxide reacts with any acid? For example, HCl. Okay, HCl, when they react with acids, okay, they form what? Salt. Which is the salt when lithium oxide reacts with hydrogen chloride? It is lithium chloride, correct? Okay, which is the salt formed when sodium oxide reacts with HCl? Sodium chloride. Then what? Potassium chloride. Then rubidium chloride. Then cesium chloride. Okay, along with the formation of what? Water. Along with the formation of water, isn't it? Since the oxides of alkali metals are basic in nature, they react with acids to form salt and water. Again, I'm telling you, don't worry about balancing the reaction. Just understand what products are formed and how the reaction is taking place. That's it. Is that simple? Okay. Any doubts? Fine. That's very nice. That's very nice. Now, okay, please understand this. Okay, let me write it here. This is one part. Say I told you, when lithium directly reacts with oxygen, it forms normal oxide. Okay, when sodium directly reacts with oxygen, it forms sodium peroxide. Okay, this has been asked many times in NEET examination. So please concentrate. Please concentrate. Okay, yes. So when lithium is directly reacting with oxygen, it forms lithium normal oxide, sodium forms peroxide, whereas okay, potassium, rubidium and cesium, they'll form superoxides, isn't it? Now treat these various oxides with water. Treat these various oxides with water. Lithium oxide, when reacts with water, it forms, look here, it forms lithium hydroxide. It is forming what? Lithium hydroxide. When sodium peroxide reacts with water, it forms sodium hydroxide and hydrogen peroxide. Hydrogen peroxide. Okay, H2 plus O2, H2O. Or if you want, you can also balance this reaction like this by taking 2 molecules of water. Okay, here also by taking, okay, yes, 2 molecules of lithium hydroxides are formed, 2 molecules of sodium hydroxide are formed, correct? Okay, you can balance it, no doubt. Okay, when potassium superoxide reacts with water, see the product form, it forms potassium hydroxide, hydrogen peroxide, and it liberates oxygen gas. See the difference here. When lithium normal oxide reacts with water, lithium hydroxide is formed. When sodium peroxide reacts with water, it forms sodium hydroxide and hydrogen peroxide. When potassium superoxides, rubidium superoxide and cesium superoxide reacts with water, they form hydroxides, hydrogen peroxide and oxygen. Hydrogen peroxide and oxygen. Okay, so this is about the reactivity of alkali metals with oxygen. Now let us understand the reactivity of alkaline earth metals with oxygen. Okay, yes, reactivity of alkaline earth metals with oxygen. Alkaline earth metals with oxygen. Okay, yes, so with alkaline earth, what are the different alkaline earth metals we have? We have beryllium, magnesium, calcium, strontium and barium. When beryllium reacts with oxygen, magnesium reacts with oxygen, calcium reacts with oxygen, strontium with oxygen, barium with oxygen. Look here, when these alkaline earth metals react with oxygen, they form, all of them will form normal oxides. There is no difference here at all. All of them will form normal oxide. Beryllium will form beryllium oxide, magnesium will form magnesium oxide, calcium will form calcium oxide, strontium will form, okay, strontium oxide, and barium will form barium oxide. Okay, you can balance the reaction, no doubt. Okay, yes, you can balance the reaction. Got it? Okay, so when alkaline earth metals, even if they react directly with oxygen, no, you don't, okay, no need to dissolve it in liquid ammonia. Even if they react directly with oxygen, all of them will form same type of oxides. What is it? Normal oxide. Normal oxide. But if these normal oxides are heated to about 500 degrees centigrade, okay, if these normal oxides are heated to about 500 degrees centigrade, okay, they will form peroxides, okay, and when these peroxides are heated to 700 degrees centigrade, they decompose to give back metal oxide, they decompose to give back metal oxide and oxygen. Metal oxide and oxygen. Are you getting it? Okay, yes. So once again I'll repeat, when alkaline earth metals, you don't have to dissolve it in liquid ammonia, they react directly with oxygen to form, all of them will form same type of oxides, that is normal oxide. When these normal oxides are heated to about 500 degrees centigrade, they form peroxides. When the peroxides are heated to about 700 degrees centigrade, it decomposes to give back again metal oxide and oxygen. For example, look here, okay, look here, when beryllium oxide is heated to about 500 degrees centigrade, it forms beryllium peroxide. Okay, when beryllium peroxide is heated again to about 700 degrees centigrade, okay, it decomposes to give back again beryllium oxide and oxygen. Beryllium oxide and oxygen. Okay, is that simple? Okay, fine. Now see, all these oxides that we have, all of them are again basic in nature. All these oxides are again basic in nature except beryllium oxide, where beryllium oxide is amphoteric in nature. Beryllium oxide is what? amphoteric in nature. Amphoteric in nature. Are you getting my point? Okay. Whereas the rest of the oxides are basic in nature. Basic in nature. Okay. Yes. Again, that means these oxides reacts with acids to form salt and water. What do you mean by amphoteric? This means that it reacts both with an acid as well as a base. Okay, it reacts both with acid as well as a base. Now, let us understand the reactions of these oxides with acids and base. Okay, simple. Okay, so all these oxides are basic in nature except beryllium oxide, which is amphoteric in nature. Only few elements will form amphoteric oxides. Only few elements. Okay, which are those elements which form amphoteric oxides? Look here, note this point. Again for NEET. Okay, again for NEET. Only few elements will form amphoteric oxides. Which are those few elements? Beryllium, aluminium, tin, lead, zinc, copper. These elements will form amphoteric oxides. Only these elements will form amphoteric oxides. Please, okay, hope you remember this. Okay, so now I'm going to write the reactions of these oxides with acids and the reaction of this oxide with acid as well as base. Okay, yes, okay, yeah. Now look at here. Look at here. Yes, I have beryllium oxide, which is amphoteric in nature, isn't it? It reacts both with acid as well as base. Beryllium oxide, magnesium oxide, okay, calcium oxide, strontium oxide and barium oxide. These are basic in nature. That means they react with acid. They react with acid to form salt and water. Which is the salt formed when magnesium oxide reacts with hydrogen chloride? Yes, magnesium chloride, then calcium chloride, then strontium chloride, then barium chloride, along with the formation of what? Water. Along with the formation of water. Got it? Okay. What about this beryllium oxide? It reacts both with acid as well as a base. If I write it with acid, look here. Okay, if I write the reaction with acid, which is the, okay, it forms salt and water. Which is the salt formed between beryllium oxide and HCl? Yeah, beryllium chloride plus water, salt and water. What if beryllium oxide reacts with a base such as sodium hydroxide? Okay, sodium hydroxide. Okay, yes, it forms a peculiar compound. What is that compound? Look here. It is going to form, okay, Na2BO2. Na2BO2 plus H2O. H2O. This is called as sodium berylate. What is this called as? Sodium berylate. Berylate. Understood? Okay. So like this, even other amphoteric oxides also. As I said, okay, zinc will form amphoteric oxide. Aluminium will form amphoteric oxide. Okay, yeah, tin will form amphoteric oxide. Okay, yes, lead is going to form amphoteric oxide. Correct? Okay, yes, copper will form amphoteric oxide. These amphoteric oxides will react peculiarly with base. Okay, like sodium hydroxide to form a different compound. What is that? Okay, sodium berylate. Sodium berylate. Any doubts with this? So this is how alkali metals and alkaline earth metals react with oxygen. React with oxygen. So that completes the first reactivity. What is it? Reactivity towards oxygen. Now let us talk about the next reaction. What is it? Reactivity towards water. Reactivity towards water. Reactivity towards water. The second reaction. Reactivity towards water. Okay, yes, I'll take both. Okay, alkali metals and alkaline earth metals. Alkali metals: lithium, sodium, potassium, rubidium, cesium. Okay, alkaline earth metals: beryllium, okay, magnesium, calcium, okay, strontium and barium. Okay, what happens when alkali metals reacts with water? What happens when alkali metals reacts with water? Okay, yes, whenever alkali metals reacts with water, look here, they form hydroxides. They form what? Hydroxides, and they liberate hydrogen gas. Okay, again, don't worry about balancing the reaction. We just want what products are formed and how the reaction takes place. Okay, yes, see, when alkali metals react with water, they form hydroxides, and there is liberation of which gas? Hydrogen gas. The same, every alkali metal will react in a similar way. When sodium reacts with water, it forms what? Sodium hydroxide with the liberation of hydrogen gas. Okay, yes, potassium forms potassium hydroxide with the liberation of hydrogen gas. Rubidium reacts with water to form rubidium hydroxide with the liberation of hydrogen gas, and cesium forms cesium hydroxide with the liberation of which gas? Hydrogen gas. But see the nature of this reaction. This reaction is highly exothermic. The reaction is highly exothermic. Okay, that means large amount of energy is released. Okay, it is highly exothermic. Since large amount of energy is released, this hydrogen will catch fire. This hydrogen, okay, hydrogen liberated will catch fire, which leads to explosion. Which leads to what? Explosion. Okay, that is why, okay, I hope you have learned this in your lower classes. What happens when you drop a piece of sodium into water? It blasts, it will explode. Why? When sodium is added to water, it forms sodium hydroxide along with hydrogen gas is released. This reaction is a highly exothermic reaction. Large amount of energy is released, due to which the liberated hydrogen will catch fire. That is why it leads to what? Explosion. Hence, we cannot expose these alkali metals. Directly into air. What happens when alkali metals are exposed to air? Okay, when alkali metals are exposed to air, they might react with the moisture. Okay, they might form hydroxide, they might liberate hydrogen gas. Again, the reaction becomes exothermic and it might explode. So that is why we can't expose these alkali metals directly to air. Okay, so what is that we're going to do is, we will, okay, yes, we will, okay, yeah, store these alkali metals in kerosene. We'll store sodium, potassium, rubidium, cesium in kerosene. But lithium is not stored in kerosene. It is wrapped by paraffin wax. It is wrapped by what? Paraffin wax. Are you getting my point? It is wrapped by what? Paraffin wax. Okay, any doubts? Okay, so sodium, potassium, rubidium, we cannot expose any alkali metals directly to air. They might catch fire. Hence, they are stored in what? Kerosene. Okay, they are stored in kerosene. Whereas lithium, since the density of lithium is less than that of kerosene, it is not stored in kerosene. If lithium is stored in kerosene, it will float on the surface of kerosene. So that is why lithium is not stored in kerosene. It is wrapped in, okay, paraffin wax. Understood? Now, how about alkaline earth metals? Even these alkaline earth metals, when reacts with water, okay, what happens when alkaline earth metals reacts with water? See, beryllium does not react with water at all. Okay, beryllium does not react with water at all. Whereas magnesium reacts with hot water, calcium with cold water, strontium with cold water, barium with cold water. All the reactions that I have written here, it is in cold water only. Okay, but here, look here, beryllium, it will not react either with cold water or with hot water. Magnesium reacts only with hot water. calcium, strontium and barium react with cold water also. Okay, what will be the reaction? Yes, what happens when magnesium reacts with hot water? Yes, it forms magnesium hydroxide with the liberation of hydrogen gas. Calcium reacts with cold water to form calcium hydroxide with the liberation of hydrogen gas. Okay, strontium hydroxide with the liberation of which gas? Hydrogen gas. And lastly, barium hydroxide with the liberation of hydrogen gas. Okay, so this is how alkali metals and alkaline earth metals reacts with water. So in the next video, we will go with the next chemical reactivities. Hope you have understood. Thank you.